Okay, so in the previous video, I explained the basic framework. The idea is you have a belief with no evidence, without evidence, but you would like to test it. That is hypothesis testing. So you are going to collect data and check if the data are consistent with your hypothesis, your belief. And if your belief turns out to be wrong, then you are going to reject it. That is obvious. But it is actually not that easy to define when your belief is wrong. For example, let's think about this. You are doing a coin toss, and you believe that the coin is fair, like heads and tails are 50%, right? However, suppose that you try coin toss 10 times, and all 10 times you see heads. Then, is the coin fair? Hardly. I won't be able. I wouldn't believe that the coin is fair. So if you see heads 10 times in a row, then I would think the coin has some problem, or it's a fake. There is some tricks. But statistically speaking, it may be wrong because it is possible. Even if the coin is fair, still it is possible that all 10 times heads happen with the probability 1 over 2 to the exponent of 10. Even if that probability is really, really small, but it is possible. So you cannot rule out the possibility that the null hypothesis is correct, but you are just unlucky. That is possible, but in statistics, anyhow, we have to ignore this small probability to make the decision, right? If you believe your belief, if you keep your belief until its probability 0, then you are going to never reject it. So if the probability of the if you can calculate the probability that your belief is correct is low enough, you have to reject it. That is a statistical way of thinking. I'm going to show you an example. So suppose that an airline company allows free cancellations for their reservations. And suppose that if you are just a good customer, you may cancel your reservation with 20%. It's literally accident. There may be accidents, like you may be sick, your business trip may be canceled by another reason, or there are reasons for fair reasons for cancellations. And we are going to assume cancellations are independent. But the problem is the airline company's problem is the existence of abusers. There may be people who abuse the free cancellation policy by making more reservations than they need and cancel them, right? So I want to use multiple seats, right? I want the seat next to me empty. So then what I can do is I can make another reservation next to me and cancel that right before the flight if cancellation is free. So this kind of abuse is possible. Then now I'm going to think it as a hypothesis testing problem. So there is a customer, and suppose that you are the airline company CEO, and you believe that a customer is a good customer, right? Does not abuse the policy. But if you believe some customer is an abuser, then you have to ban, right? You have to put some penalty on the abusers. So how can we do that in hypothesis testing? To do that, let's think about another example. Suppose that there are two suspicious customers. Customer A canceled her reservation 3 times out of 5 reservations, right? But customer B made 100 reservations in the past, but canceled 30 times. Who do you think is more likely to be an abuser? If you can ban one of these two customers, who are you going to ban. So there is so either way it is okay, but I guess typically most of you may think this way. So customer A canceled 60% of the reservations, but customer B canceled only 30%. So the percentage of cancellation is much higher for customer A. So I'm going to ban customer A. That makes sense. That is also reasonable statistical thinking. But I'm going to introduce another story. I will ban customer B first. So, hear me. So, what we need to do here is, the probability I'm going to calculate will be like this. I will believe that they are not abusers. They are good customers. So, still, however, they may cancel the reservations. Their reservations may be canceled by chance. That is possible. So I am going to calculate the probability of these many cancellations, when they are good customers. Okay, we can calculate that because we know the distribution follows a binomial distribution, right? We assumed cancellation probability is 20% and independent. So we know how to calculate that. So this is the binomial distribution probability. So when you think about customer A who made 5 reservations, probability of canceling all 5 reservations is small but not 0, 0.03%, because this customer may be really unlucky, so she may have to cancel all of her reservations by chance. Also, and because 20% is the probability of cancellation, or 1 is most likely, 1 out of 5 is the most likely outcome. But anyhow, you can calculate probability of non-cancellation out of 5 times, and 2 cancellations, 3, 4, 5, using the binomial distribution. Okay? So then what I'm going to assume is, definitely the more a customer cancels the reservations, the more suspicious, the more likely the customer is an abuser, right? So we are going to then, based on that idea, if we are going to ban customers, we are going to ban this group first, and then this group, and then this group. So we are going to start to ban customers from the most suspicious group. Okay? So let's put it this way. If you ban the customers who canceled 5 out of 5 times, then 0.03% of customers, good customers, will be banned, right? So we are assuming everyone is good customers. So they are they had to cancel the reservations by chance. So 0.03% of innocent customers will be banned. But if you lower the standard to 4 cancellations, then 0.67% of customers will be banned. So, and if you even lower the bar to 3 cancellations, the probability will become 5.79%. So 5.79% of innocent customers will be banned. That means what I'm telling you here is, there is no certain things. There is no certainly abusers. So even if a customer cancels all of her reservations, still that customer may be innocent. That is possible. However, you have to ban. The customer is just unlucky, but it is more likely to be this probability is too low, so you need to sacrifice that much probability. It is similar to the idea that when you see 10 heads from a coin toss, you need to think about unfair coin, some kind of tricks there, right? It is not because it is 0%, but because the probability is really low. it's like this. Probability is too low. So even if the customer was innocent, it is really unlikely to cancel all the reservations. Okay. So then the question is, then what you have to do is, so okay, how much am I going to sacrifice, right? So I said you need to sacrifice certain amount of innocent customers. Then are you going to sacrifice this much or a little more or this much? That is your choice. So you have to have your own standard in terms of probability of the innocent customers. Okay. So I am going to now. What I'm going to do is I'm going to use the probability as the ranking of suspiciousness. Right. The most suspicious customer is 0%, and the least suspicious customer is 100%. Right. So that means if you're going to ban 1% of customers, that means you are going to ban top 1% from 0 to 1% customers because they are most suspicious. It is a kind of ranking. Okay, so customer A's ranking is 5.79%. 5.79% is the sum of these three probabilities. So customer A is in this group. So this group is top 5.79% from the most suspicious customer. Okay, so think it as a ranking. Then, okay, so remember customer A's ranking is 5.79%. Now we are comparing this customer to customer B, who canceled 30 times out of 100 times. So we are going to compare the ranking between customer A and B. Okay. So now we will change the distribution, shape of the distribution, because the reservations are now 100. So the parameter for the binomial distribution is now 100. In this case, the binomial distribution is more like a normal distribution by the central limit theorem. It is centered around 20 because on average, out of 100 times, 20 times will be cancelled. Okay. Also, note that even though there seems zero probability here, but actually there are extremely small probabilities everywhere from 0 to 100. Just they are too small. It's really, really small, so it is not seen here. But remember, it is not zero. But and again, the more cancellations, the more suspicious, which is obvious. And then, in this case, we know customer B is here. Customer B canceled 30 times, which is here. So then the ranking is counted from the most suspicious group. So then we are going to calculate the probability that way. Then you get 1.12%. So customer B's ranking is higher. That means customer B is more suspicious, right? Right? Because the ranking, the smaller, 0% is the most suspicious, 100% is the least suspicious, and customer B is only at 1% group, but A is a 5% group. So B is much more suspicious than A. Okay? So this is my logic, and this is how hypothesis testing works in statistics. So back to the question, it is not a matter of average percentage, sample average or sample percentage. What you do here is, remember, I assume that the customer is innocent, is a good customer. And then I calculate the probability of these outcomes. So in other words, I rank the suspiciousness using the probability of these outcomes. Okay? That is what we are going to in this chapter. Okay? So, we will formulate this idea into a hypothesis testing decision rule. So first, in statistical framework, we will set up hypothesis here, like this. So I have to believe that a customer is innocent. That is my belief. Without any observation, without any evidence, I have to believe that my customers are innocent. So I believe that cancellation probability is 20%. But if a customer is an abuser, the probability of cancellation would be greater than 20%. That is the definition of abuser, right? So we set up our hypothesis. That is the first step. And second step, what you need to do here is you need to determine how much probability you are going to sacrifice or how much probability you are going to ignore, right? So we call that significance level. It is denoted as alpha. So that means if the probability, any probability below alpha is not significant, I'm going to sacrifice the probability below alpha. So usually also, similar to the confidence interval, confidence level, the typical choices are 1% or 5% or 10%, right? It is typical choices. Later in mathematical derivation, you are going to see that this significance level is very much similar to the confidence level in confidence interval, okay? Anyhow, the idea is the name significance is coming from the fact that your decision that probability smaller than this threshold is insignificant. That is the basis of your decision, okay? And then in other words, if you increase the significance level, that means you are going to ignore more or you are going to sacrifice more innocent customers, okay? So if, for example, if you choose 5%, that means you are going to ban top 5% suspiciousness group. That means 5% innocent, 5% of innocent customers will be banned just because they are unlucky. That is the significance level. So if you increase that, you are going to ban more customers. You are going to reject more null hypothesis. So, and a little more. How do you do that? We will determine a test statistic first. So we usually denote it as T. Calculate a test statistic. You may this is the counterpart to an estimator, right? From the data, you calculate some statistic, and that would be the basis of your decision. If this is too large or too small, you are going to reject, something like that. So test statistic is based on the data. And what I'm going to do is, what the main thing here is, by the way, in our examples, we are going to use the sample mean as a test statistic, right? So as I said, test statistic is similar to an estimator. So like back to this example, you may think that probability would be a possible test statistic. And then what we need to do here is, once you calculate the test statistic, you need to think about the sampling distribution of the test statistic under the belief that your belief is true. Under the belief that the null hypothesis is correct, in our example, under the belief that the customers are innocent, what would be the probability distribution of the cancellations, number of cancellations? That is called null distribution, right? And remember, the point here is we are assuming the null hypothesis. We still believe that. In calculating the sampling distribution, we believe, like in our example, we believe cancellation probability is 20%. Everyone is innocent. Let's calculate the distribution. That is the null distribution. Okay, so this is a little more concrete example that illustrates how we are going to test a hypothesis. So in the next video, we will use even more concrete example and more numerical example to show you how to implement hypothesis testing. Okay, thank you for watching. See you later.